Begin factoring polynomials on today. So we're going to start off with factoring polynomials using the distributive property. And we're going to be talking about greatest common factors. A greatest common factor is basically the biggest number that a set of numbers have in common. Basically, what's the biggest number that divides evenly into two numbers? So if I'm asking you what is the greatest common factor between 8 and 10, I can find that out by listing the factors of 8 and 10. Factors are two numbers that multiply to give me a number. So two numbers that multiply to give me 8, 1 and 8, and I can multiply 2 and 4 to give me 8. There are no other numbers that I can multiply to give me 8 besides 4 and 2 and 8 and 1, which is the same thing. Well, what about two numbers that multiply to give me 10? I can multiply 1 and 10 and 2 and 5. There are no other numbers I can multiply to give me 10. Therefore, that's it. Now, what's the biggest number that 8 and 10 have in common? Yeah, both have a 1 in common, but it's not the biggest. So the greatest number that they have in common is 2. So the greatest common factor between 8 and 10 is 2. Well, let's do a bigger number. What about 30 and 45? If I want to find out the greatest common factor between 30 and 45, I need to list the factors. Two numbers that I can multiply to give me 30. 1 and 30, 2 and 15, 3 and 10. I can't multiply 4 by anything. 5 and 6. So I can multiply these numbers and they would give me 30. Well, what about 45? I can do 1 and 45. I can't do 2 and a number. What about 3? We can do 3 and 15. I can't do 4. We can do 5 and 9. I can't do 6. I can't do 7. Can't do 8. So these are the only numbers that I can multiply that's going to give me 45. So the question is, what is the biggest number between 30 and 45? They do share 1. They also share 3. They also share 5. But the biggest number that they share is 15. So the greatest common factor between 30 and 45 is 15. Well, we also have to be able to tell greatest common factors from variables. And when we find greatest common factors from variables, it's basically what do they share? So x squared and x to the power of 4. Remembering that an exponent tells me how many of the variables I have. So the factors of x squared are x and x because it's 2 of them. The factors of x to the power of 4 is 4. Now, to find the greatest common factor between x squared and x to the 4th, how many do they share? 2. They don't share 3 because x to the squared only has 2 x's. They don't even have 3 x's to share. So the greatest common factor between x squared and x to the 4th is only x squared because they only share 2 x's. Well, what about y and y cubed? So just for y, it only has 1 y. Well, what about y cubed? That means it has 3 y's. Well, how many y's do they share? Only 1. They can't share 2 y's because y only got 1. So the greatest common factor between y and y cubed is simply y because that's what they share. All right, let's do one that has 2 variables. So a squared and b cubed plus ab squared. Remembering that the exponent tells me how many variables I have. So a squared means I have 2 a's. B cubed means I have 3 b's. Well, for the second term, a just means I have 1, and b squared means I have 2. Now, I'm trying to find the greatest common factor of those two terms. So what do they share? Well, they don't share any more a's. Well, what about b's? They share 2 b's. So the greatest common factor between a squared b cubed plus a b squared is 1a and 2 b's. So that backdrop lesson was to take us into factoring a polynomial by finding the greatest common factor. So to find the greatest common factor of a polynomial, we have to find the greatest common factor that is in common with all of the terms. We can't pick one term. We can't pick two. If it's three terms, we have to find the greatest common factor, the number or variables that's in common for the entire polynomial. And so we have to do this for the numbers and the variables. So if I'm looking at 5a squared minus 10b plus 20, I'm trying to find the greatest common factor that all of those share. So I would have to find factors of 5, factors of 10, and factors of 20. So factors of 5 are 1 and 5. Factors of 10 are 1 and 10 and 2 and 5. Factors of 20 are 1 and 20, 2 and 10. Can't do 3, 4 and 5. Can't do 6, can't do 7, can't do 8, can't do 9. Okay. So those are the only factors. What is the greatest factor that all of those share in common? 5. So the greatest common factor between 5, 10, and 20 is 5. So I can factor out a 5. Well, what about variables? Well, this only has 2 A's. And this one only has 1 B. So they literally don't share any variables because the variables are not common through all of the terms. So the only thing that I can factor out is a 5. And when I say factor out, this is what I mean. So between 5, 10, and 20, the greatest common factor is 5. If I factor it out, that means what does it leave behind? Basically, it's division. So if I factor out a 5 from 5a squared, meaning 5a squared divided by 5 leaves me what? Leaves me a squared. Well, what about negative 10b divided by 5? Because that's what I factored out. Well, that leaves me a negative 2b. Because negative 10 divided by 5 is a negative 2. I'm having some difficulties. And 20 divided by 5, notice those are all of my terms, is a positive 4. So when I factored out the greatest common factor between those three terms, I'm left with 5 times a squared minus 2b plus 4. Now, if I distributed this, if I distribute 5 to each one of my terms, it should give me my original polynomial. This is a checking. This is how you check yourself. So 5 times a squared, 5 times negative 2b, and 5 times a positive 4. Therefore, we factored it out correctly. All right, what about some variables? X squared y plus 9x. So I'm going to look at the numbers first. They don't have any numbers in common. Well, what about variables? Well, this first term has 2 x's and 1 y. And the 9x only has 1x. So how many variables do they share? They only share 1x. So I can factor out that 1x. Well, when I factor out the 1x, what does it leave behind? I took an x from x squared. So if I had 2 x's and I took 1 away, that means I have 1 left. I didn't touch the y. Well, what about from 9x? I took out an x from 9x, so that leaves me with 9. All right, 7x cubed minus 14x squared minus 32x. That means I need to find the greatest common factor between all of those terms. And between 7, 14, and 32, I don't think they share any numbers, but we'll see. Factors of 7, factors of 14, and factors of 32. They don't share any numbers. Well, what about variables? Well, this has 3 x's, we have 2 x's, and we have 1 x. So how many x's do they share? They only share 1. So I can only pull out 1 x. When I pull out that 1 x, what does it leave behind? So from 7x cubed, if I pull out 1 x, then that means it leaves 2. From negative 14x squared, if I pull out 1 x, that means it only leaves 1. From negative 32x, if I pull out a x, it only leaves a negative 32. All right, 8a cubed b cubed minus 4a b cubed, 4a squared b squared. So I need to find my factors of 8. I need to find my factors of 4. So 1 and 8 and 2 and 4 and 1 and 4. What is the greatest number that 8 and 4 share? Obviously, it's 4. So I can factor out a 4. Well, what about my variables? Well, they have 3 A's and 3 B's. Well, what about my second term? It has 2 A's and 2 B's. Well, how many A's, how many B's does it share? So they share 2 A's and they share 2 B's. So I can also pull out 2 A's and 2 B's. Well, when I factor that out, what does it leave behind? 8 divided by 4 is 2. 3 A's, and I took away 2 A's, that leaves 1. 3 B's, and I took away 2 B's, that leaves 1. 4 divided by 4 is 1. I had 2 A's, I took them away. Had 2 B's, took them away. And last but not least, some special ones. So a times a minus 7 plus 9 times a minus 7. What is the greatest common factor in this term? Remember, greatest common factor is 2 things that are being multiplied that they have in common. Common means more than 1. So I see a minus 7 2 times. So I can factor out a minus 7. And when I factor out a minus 7, what does it leave behind? A plus 9. So x squared times x plus 2 minus 7 times x plus 2. What is the greatest common factor that they share? X plus 2. So I can pull out x plus 2 because that is my greatest common factor. Because I see it more than one time. It's common. What is left behind? X squared minus 7.